ANSYS Simulation Lecture 16, Harmonic Response Problems. This is the 3D model, and this is the ceramic of piezo and an aluminum horn. So we enter ANSYS Workbench, drag model analysis and harmonic response. Make sure that you drag it to model, not solution. If you drag it to solution, it will become a mode superposition problem instead of direct integration. So we are running a full model. So we'll delete this link. Make sure that there's no link between the solution and setup here. So we are running a full solution. Now we're going to edit the material. First of all, I will include a aluminum alloy for the horn, and then I will duplicate the structure steel and rename it to piezo. The density will be 4.5, and I'll drag orthotropic elasticity into piezo, and then enter the mechanical properties of the piezo material, the Young's moduli. Poisson's ratios. Shear moduli. And these are the mechanical properties of the piezo material. So we go back to project and enter ANSYS mechanical. And we're going to enter electrical properties of the ceramic, piezo ceramic, in mechanical procedure. So for the geometry, the horn will be aluminum alloy. The piezo will be piezoelectric material. And then we'll insert commands for electrical properties of the piezo. And these are dielectric permittivity of the piezo material and the piezo matrix of the material. So these are the material properties. And then for the contact, I will leave it as bounded. And for the mesh, first of all, I'll make a map mesh for all the surfaces, and then insert a method and choose all volumes and make it hexagonal dominant, and all the surfaces are four-sided. And then I'll generate mesh. And for the boundary condition, I'll fix the bottom surface. And then for the loading, I'll impose a voltage on the electrodes. So I'll define the surface of the electrode. On the bottom surface, I'll create name selection to be positive electrode. And I'll hide this body and name the up surface to be negative electrode. So I have two electrodes, positive at the bottom and negative at the top. Show all bodies. And now I'll insert a command, a D command, on positive electrode, volt, 700 volt. D command, negative electrode, volt, grounded. So this is the electrical voltage are imposed upon the electrodes. And now I'll set the number of eigenvalues to be 11. And since I have written commands, I need to set the unit to be manual, MKS unit, so that the unit of the command is the same as that of workbench. And I'll save all the commands, and then I'll run the frequencies. And the frequency is 3921, and then I'll create the mode shapes and update all the mode shapes. And the sixth mode will be translational, which is what I need. So I remember that the frequency will be 3921.5. And then I'll enter the harmonic response solution. I'll copy the boundary condition and loading to harmonic response. And then since we have commands here, so I have to define the unit to be manual also. And the unit will be MKS unit. And I will save all the commands. And also, since the frequency is 3921.4, so I'll set the minimum to be 3900, and upper bound maximum would be 4000, and I'll run 50 intervals for it. Make sure, it is very important that we run a full analysis instead of mode superposition. So make sure that you change the superposition solution method to full analysis. This is very important. And so we have boundary conditions and loading, and also we set the ranges of the frequencies, and make sure that the solution method is full solution, and then the unit will be manually set to MKS. So now for the result, we need a frequency response for the deformation at a point here, this point, in the Z direction. So this is the direction that we really need for the horn to displace. So this is the frequency response. And phase response for deformation, we can also choose this point. And I'll enter the frequency as 3921.4. The frequency at here, the translation of frequency. So we can solve for the harmonic response. And the result here, we have 50 steps, so it may take a little bit of time to run all the 50 steps. And the result here, you can see that at the frequency of 3921, the amplitude is very large. So in harmonic response, you can push a very large structure using a very small piezoelectric material using harmonic response. So for example, in this problem, we are dealing with the problem of ultrasonic vibrator or ultrasonic welding machine, and we can push the whole structure with a very small piezoelectric ceramic material. And the phase response is like this. So this is the lecture 16, harmonic response analysis.